Hello everyone, welcome back to my channel. This is the fifth video of my channel. So in this video I am going to realize an XOR gate using IC number 7486. Before going to the experiment, we will see the logic symbol and the truth table of XOR gate. So this is a logic symbol of XOR gate which is having two inputs A, B, and having the output as y equal to A XOR B. This is a symbol of XOR, that is this plus with circle. This is a symbol of XOR. Now if we look at the truth table, so truth table is that it is having an input as A, B and output as Y. Basically the truth table is in this format, that is when both the inputs are 0 0 it is going to be a 0, when one input is 0 and other input is 1 it is going to be a 1, and one input is 1 and other input is going to be a 0, then it is going to be 1, and one input 1 other input 1 it is going to be a 0. So it means it shows such that when both the values are low it is low, when both the values are high it is low, when one value is high it is going to be high. So the truth table basically tells us that when both the value are low it is low, when both the value are high it is low, when one value is high it is going to be high. So this is the truth table what it is going to say. Today I am going to tell one new concept, that is K-map. I have not used it in any previous video. I am going to use it in this video to derive the equation of this Y output. So K-map is found basically using the truth table. So for this particular inputs we are having only 2 into 2 K-map. How you know that it is 2 into 2 K-map? That is input are 2, so it is going to be 2 raised to 2, that is it is having a formula as 2 raised to n. So your total inputs are 2, so n equal to 2, so n equal to 2 means the value is going to be a 4. So totally 4 type of output are going to come. So we are using a K-map of 2 into 2, that totally there we are going to put only 4 outputs. So the K-map of 4 input is going to be in this format. So this is a 4 input format K-map. So here it is A input and here it is B input. We are going to put in the format of this. So here it is in format of putting an K-map. This is I am teaching today 2 into 2. In other some videos I am going to teach all other K-maps, such as this input is going to be A bar and this is A and this is B bar B. B bar B. A bar is nothing but a complement. What is a complement? When A is equal to 1, its complement is going to be 0. This is the meaning of complement. And here we are going to make a numbering 0, 1, 2, 3. So we have made a numbering here 0, 1, 2, 3. Now we have to use the outputs of this truth table. So the outputs are basically 0, 1, 1, 0. So this is going to be 0, 1, 2, 3. So these are the numberings, that is 0, 0 is 0, 0, 1 is 1, 1, 0 is 2, 1, 1 is 3. So in the binary format I have written it in a decimal form. So we are going to mark the same as it is. So for 0 it is 0, so we will mark it in the 0th box. For 1 it is 1, so we are going to mark it in the 1th box. So for 2 it is again 1, so we are going to mark it in the 2nd box. For 3 it is 0, so we are going to mark it in the 3rd box. So wherever the output is 1, we are going to mark it with this pen. So it is this and this. It is in the, they are in the different places, that is this is in the single, this is single. If was the condition in this format, that is here 1, here 1, we are going to circle it with one circle. This was a different case. We will see it in the many other videos. I will show how to do this K-map. We will learn this K-map first. So now we have got it in the different boxes. So the output is going to be in such a way that y. So first we will see this one. So that is, what is the here, it is a b, and here the common is a bar. So to this box it is a bar and b. So we are going to write them. So a bar into b, that is a bar b plus, then, and if you see this one, the common is b bar and a. So this is going to be a b bar. So this wholly we are going to write it in this format, that is a XOR b. So this is the output what we are getting from it. So to verify this truth table, we can use this equation too. So to verify it, y equal to, if we give the input as a bar, so a bar, so a is what, 0, so a bar is going to be 1, and b has it is, that is 0, plus a has it is, that is 0, and b bar, that is going to be 1. So what is the calculation you are going to get? 1 into 0, 0, 0 into 1, 0, that is 0. So output is already came here 0. You can test other all the outputs by putting this value in this equation. You will get the output. So try this one. So now we are going to implement this using the IC number 7486. So here is the IC I have connected it to the breadboard. So it also has the same pins like in the NOT and all. So I am going to show the internal diagram of this IC. It may be coming on the screen. Observe it carefully. It also has a 4 XOR gates. 4 XOR gates, and here are 7 pins, and this side it is 7 pins. So this pin is of ground, 7th pin, and this 14th pin is VCC. So here I am going to use this first 2 pin and third pin. First 2 pin are the inputs of one gate, and third pin is the input of first gate. It continues same way. This 1, 2, 3, after 4 and 5 are 2 pins of inputs of second gate and output of second gate. It repeats the same here. You may be observing in the diagram, it is clearly shown. So let's start connecting it. So first I am going to connect an wire for VCC. First always connect the VCC and ground. That is the first thing must be done. So this is connected. So this I have connected as a VCC here. This line I am going to make as a VCC. So next I am going to connect this one as a ground. First thing must be always done this VCC and ground. So next thing I am going to give 2 inputs here. So I am going to leave 2 open wire at the place of 1 and 2. So I have left 2 wires. First wire is for input of A and second wire is for input of B. So these 2 wire I have left at 1 and 2. Now I am going to give one LED at the place of the third pin for output. So this is an LED. This is an LED which I already explained about it. The longer strand of the LED is an positive and smaller strand of the LED is an negative. So the positive strand should be connected to the output of the IC, that is I have connected it to the third pin, and shorter pin must be grounded here, that is at this place. This I am going to make an ground line, and this is connected. So these are the connection has to be made, and the battery must be given. So this is the battery I am using, that is of 9 volt, but it must be used and 5 volt. So I am going to connect an resistor at this place. So this is the complete connection. So I have given one resistor here. In place of wire I have put one resistor, and which is connected to VCC, and this is ground, and these 2 wires are for input. This yellow wire and red wire, yellow is A and red is B, and this is a battery connection. I have made this whole line as a positive and this whole line as a negative, and this is an LED for output. So to clarify the connection for in the more clarity, I am going to show in the paper, that is I have given 2 lines. that is this is for positive and this is as a ground, and I have connected here, that is 14th pin, and here I have connected a 7th pin of the IC, and one gate of the IC I have used, that is the XOR gate of the IC, and this is the first pin. I have given one out input, two open wires, and this is 2, and here I have connected an LED. Here I have connected an LED, that is third pin, and I have grounded this shorter stand of the LED. So this is the connection how it is made. So now we are going to verify this truth table values by giving the inputs. So let us verify these inputs. So first input is 0 0, that is A is also 0, B is also 0, the LED must not glow. So I have given A as a 0 and I will give B as a 0. So the LED got off, that is 0. So now second input is 0 1, A is 0 and B is 1. So yellow wire is a A, so red wire is a 1. So I am going to give it as a 1. So I gave it as a 1, so the LED glowed. That this verifies the second condition. Now the third condition is A is 1 and B is 0. So no, first I have checked the third condition. Now we are going to check the second condition. Second condition is A is 0 and B is 1. So now let us check the second condition, that is A is 0 and B is 1. So A is yellow wire, so I am going to give it as a 0. A is 0 and B is 1. So when I give B as 1 and A as 0, the LED is glowing. That is 0 1 LED is glowing. Now A is 1 and B is 0, so it must be exchanged. So this must be given as 1 and B must be given as 0. B must be given as 0. So this is what I have given. So the LED is glowing. So then the last input is both are 1. So this must also be put in the 1. The LED must get off. The LED must get off. So the LED got off. This is the outputs I have verified using the XOR gates. So that's it for today. If you have any doubt, you can comment down in the video. So thank you.